Okay, so greetings everyone. Welcome to this session. Today I am going to take a topic about introduction to computers, which is fundamentals of computers. My name is V. Rajeshram. My designation is Assistant Professor, CSE Department, and I am from Kumarasamy College of Engineering, Karur. Computer introduction. First, computer is a device that manipulates the information and data, so which going to perform a task for a human. Human going to give an input to the computer. Computer is going to perform that particular task by using that data given by the human and going to produce a result for that particular task. The process that will be performed by the computer using the hardware and the software, which is parts of computer. So computer parts that mainly it's a combination of hardware and the software. Here the input going to give the data to the computer going to handle that data using going to perform the task using the central processing unit, and the output will be given to the output devices. Here central processing unit that contains so many parts which will be discussed later. First of all, computer is a electronic device that going to perform some process for the task given by the user. Next, history of the computer. The mainly Charles Babbage invented the computer, which is a previous generation, that is known as analytical engine. Next, types of computer. First type is a supercomputer. So supercomputers are that is process a very large amount of information that going to perform some multiple tasks in parallel. Also, it can process a very large amount of data. Next one is mainframes. So mainframes that will be used by the government and the business process. So that is to process the same like supercomputers, large amount of information, but its process and the capacity is lesser than the supercomputers. Next one is mini computers, which is also known as similar to mainframes, that is used by the business and the governments, that is also used for process the large amount of information. That capacity is, when compared to the mainframes, it will be lesser than the mainframes. Next one is personal computers, which is also known as PC, which is used in the homes, schools, and some other small business industries. Here it is in several types, that are desktop, portable notebook or laptop, and the handheld devices. Next one is computer generations. There are 5 generations of computer. First one is vacuum tube computers. Second one is transistor computers. Third one is small scale integrated circuits. Next one is large scale integrated circuits, and last one is very large scale integrated circuits. So first one is known as first generation. In that first generation, time period is 1940 to 1956. The component used here is a vacuum tube. Here its speed is milliseconds, and its memory is magnetic drum, and the language used for that first generation computer is machine language, and the input output devices is punch card and the printout, and the example is UNIVAC and ENIAC. Second one is a second generation computer, which is in the year 1956 to 1963. Here the component used is transistor, and the speed is microseconds, and the memory used is magnetic core technology, and the language used here is assembly language, and the input output devices are punch card and the printout, which is similar to the first generation. And the example is IBM 1404 and IBM 7094 are the devices which is used in the second generation. And next one is third generation. The time period is 1964 to 1971. Components used here is small scale integrated circuit. Here the speed is nanoseconds, and the memory used here is floppy disk and tabs. The language is COBOL, Fortran, and all applications. And the IO devices are keyboard and monitor. Next one is fourth generation. It is started from the earliest of 1970s and up to now. Here we are using the fourth generation computers, and the component used here is a large scale integrated circuit, and the speed is 1 to 10 nanoseconds, and the memory used here is hard disk, CD, and DVD. Languages are C, C++, Java, Oracle, and all GUI based languages. Next one is the IO devices are keyboard, monitor, mouse, and joysticks. The examples are Apple II and Crave 1. Next one is a fifth generation. It's the last one, and now we are using the fifth generation computers, and in future also we are going to use the same. The starting year period is 1986 to at present, and the component used here is very large scale integrated circuit. Here the speed is 1 to 100 nanoseconds, and the language is third generation language and fourth generation language, and the area of mainly it is used for the artificial intelligence. Here AI is for robotics and speech recognition system, and the expert system is medical recognition and financial planning. These are the applications that is used by the computers mainly for education, banking, government, healthcare sectors, science related researchers and publishing, also the travel, and also for industries. So these are the main applications where we are using the computer nowadays. And basic organization of computer. Here computer is a device, we have already seen, it's an electronic device that going to perform a task for the humans. Here computer contains three major parts. First one is input unit or input devices, second one is central processing unit, shortly known as CPU, and third one is output unit. Input unit means that contains hardware. It's a combination of hardware and the software. Basically computer is a combination of hardware and software. Not only the computer, the parts of the computer also based on the same. It's a combination of hardware and software. Input unit means that going to get the input from the human and give it to the computer. The input given to the computer is converted into the language which is known by the computer. Modern days computer that knows only binary language, which is a combination of zeros and ones, which means zero, the numbers or letters, whatever the instructions we are given to the computer, that is in the form of zeros and ones only. Like English alphabet that contains 26 alphabet letters, likewise binary language that contains only 2 digits, zeros and ones. Using that zeros and ones only, computer can communicate with all other parts, and the instruction given by the human also converted into zeros and ones, and the data's instructions and the output generation, everything will be converted as zeros and ones. The input given to the user, that will be converted into zeros and ones. That's the task of input devices only, that will not be performed by the any part of CPU or any other devices. Input only going to give the data to the computer, which means central processing unit, and also it convert the data that will be understandable by the computer too. Here it is the basic organization of computer system. Here we have a input device that going to give the input to the central processing unit. Central processing unit, they are going to process the input, and given the produced output will be given to the output device. So mainly the input devices we know are keyboard and mouse. With that we have light pen, digitizer, trackball, OMR, OCR, MACR. So these are the some other input devices which are all used for particular purpose. In common we are using keyboard and mouse as a input device. Next one is central processing unit, which is known as the heart of the computer. Here it contains three other parts also, which is control unit, and then arithmetic and logic unit, and the memory system. Here the functions of CPU is it performs the calculations, it going to decide the process, and it controls all the parts of the computer. So these are the main functions of CPU. First, the CPU is divided into control unit, arithmetic logic unit, memory unit, and secondary storage. In the diagram, we are separately mentioned storage in the out of CPU, which is known as there's a secondary storage that can be removed from the CPU, that will not affect the functions of CPU. First one is control unit. Control unit going to control the entire computer processing, which means data flow and the process flow, instructions that will be executed by the computer, and the output sent to the output device. So everything will be controlled by this control unit only. The flow between the memory and the arithmetic logic unit also controlled by the control unit only. If the arithmetic and logic unit going to perform some mathematical operation, means that data will be received from the memory only. So to fetch the data from the memory, the arithmetic and logic unit need the permission of the control unit. With the control unit permission or instruction only, the data will be moved from memory to the arithmetic and logic unit. After performing the operation, the data will be returned to the memory system or will be output device that will be controlled by control unit. Like this, all the operations in the central processing unit or the computer will be controlled by the control unit only. In that arithmetic and logic unit, we have two different parts. It's a combination of two different parts. First one is arithmetic unit and one is logical unit. Arithmetic unit going to perform all the mathematical operations like addition, subtraction, multiplication, division and modulo division. Likewise, all the mathematical operations will be performed in arithmetic unit, and the logic unit going to perform the conditional operations. So less than or equal to, greater than or equal to, less than, greater than, not equal to, equal to, all the conditional operations will be performed in logical units only. Next one is memory unit. In that memory unit, all the data given by the user will be stored in memory unit only. So memory unit that commonly separated as primary memory and the secondary memory. Primary memory that contains devices like RAM. Secondary memory contains devices like hard disk or pen drive. In that primary memory that going to store a data when only the power is on. If there is a power loss in the system or if we shut down the system, means the data in the primary memory will be erased. Primary memory is faster than the secondary memory, and the primary memory it's costlier than the secondary memory, and primary memory that has a less capability, which means memory size is low when compared to the secondary memory. Primary memory that has some advantages and disadvantages when compared to the secondary memory. In secondary, primary memory also known as a volatile memory. Volatile memory means once the system loses the power, the entire data stored in the memory will be lost. So that's the main property of main memory or primary memory. Second one is secondary memory. Secondary memory that going to stores the maximum amount of data, which means the capacity, the memory capacity of the secondary storage is high, and it is a non-volatile memory, which means once the power loss, the data will not be erased. It will be kept inside the memory only. It is higher in memory size, and it works slow when compared to the primary memory, and the processing speed is slow. Okay, so in that secondary memory, the devices can be removable. The secondary memory device like USB we are using means, pen drive we are using means, that will be removable. That will not affect the normal system function. There is no necessary for the secondary device that must attach to the attached to the central processing unit or the computer. That is exception for the hard disk. Next one is output unit. In that output unit, the once the data is processed, the input device given the input to the computer. Once the computer processes the particular process, and the output will be produced to the output unit. The output unit mainly we are using here, using nowadays is monitor. Monitor is a primary output device that going to display the output of the particular input data given by the user and the process of that particular data. After processing, the output unit will display the output to the user. Except a monitor, we have two more primary output devices. First one is printer, second one is speaker. So these two are all the some other output devices that is used in common output devices nowadays. Next topic we are going to see about number system. In the number system, we are going to deal about the different number systems which we are using in the current world, and primarily focused on the number system that is used in the computer. How the computer processes the numbers, strings and the inputs given by the particular user. Here number system common, nowadays we are using a decimal number system which contains 10 number symbols starting from the 0, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 10 different number symbols. After 9 we are using the same combination. 0 to 9 combinations numbers only used to generate further numbers up to infinity. Hundreds, thousands, lakhs, crore, everything will be generated using these 10 number symbols only. It's known as decimal number system. For the decimal number system, we have some properties. While reading and writing in the decimal number system, we are following from left to right, which means for example, we are writing a number 768 means 7, 6, 8, which is read or write from the left to right, but the weightage of that particular number that's given from the right to left, which means 4 that has a minimum value, minimum weightage value, and then 6 has the next minimum value, and then 7 has the next minimum value. Likewise only the process will be moving from right to left, which is known as which is a main property of decimal number system. Here in the decimal number system, 0 is the main number symbol that is created by Indians only. Next we are going to use base or radix. Here base or radix is a main term that going to represent which type of number system we are using. Here base value is 2 or 10 means, here base value is 2 means that represents the binary number system. Here the 2 represents how many number symbols in that particular number system that is represented by the base value. Here 2 represents 2 number symbols in the binary number system, which is 0 and 1, which we have discussed earlier. And in the decimal number system we have 10 different number symbols, so the decimal number system base value is 10. Here the binary system numbers, we have 2 number symbols 0 and 1. Decimal number system we have 0 to 9, 10 different numbers. Likewise we have different number system like octal, hexadecimal, so we will be seeing one by one. In that decimal number system, the numbers also known as digits. Not only decimal number system, every number system we are representing each number symbol as digits. Here the position of each number symbol that has different weightage. The weightage start from the right to left alignment format. In the decimal number system we have the weightage in the format of 10 power x. The x value that is start from 0, which is from the right hand, up from 0 to we are going to increase one by one, 10 power 0, 10 power 1, 10 power 2, 10 power 3. Likewise we are moving from right to left direction. For example, we are having a number 754. Here 4 that has a weightage of 10 power 0. For the digit 5 we have a weightage 10 power 1. For the value 7 we have a weightage 10 power 2. So likewise we are moving from right to left. While we are reading or writing the number 754, we are moving from left to right, but for the weightage purpose we are going to use the format right to left. So 10 power 0 in the rightmost end, and the next position in the left hand side has the weightage value of 10 power 1, and the next position in the left hand side has the value of 10 power 2. So likewise it will be continued. For the value of 4, for the position of for the first position, actually that's a 0th position for the representation. So 0th position means that has the value 4, it has a weightage 10 power 0, so that 0 represents the digit position. Here 10 power 0 means this 0 represents the digit position when the weightage of that particular 4 is 4 into 10 power 0 value is 1. So obviously anything power 0 is 1. Here the 10 power 0 value is 1. So 4 into 1, that gives the result 4. Likewise 5 into 10 power 1. So 1 represents the position of that particular value 5. Here 4 represents the 0th position, 5 represents the first position, 5 that's placed in the first position. So 5 into 10 power 1, that gives a result 50, and then 7 into 10 power 2, so 10 power 2 means that gives a result 10 into 10, that will be 100. So 7 into 100 means 700. Here we are going to add the 700 plus 50 plus 4, the result will be 754. Likewise only decimal values get the actual their weightage. So these are the different number systems now we are using in this world. Binary number system that has a base value 2, which means that has the digital symbols 0 and 1, and ternary number system that has a base value 3, which means the digital symbols used in the ternary is 0, 1 and 2. In quaternary we have the base value 4, 0, 1, 2 and 3. In the quaternary we have 5 base values, which means 0, 1, 2, 3 and 4. In the octal we have a base value 8, which is 0, 1, 2, 3, 4, 5, 6 and 7. So these are digital symbols in the octal number system. In the decimal number system we have already seen the base value is 10, and the digital symbol that contains 0 to 9, and the duodecimal that has the base value 12 from 0 to 9. And the for remaining two numbers we are using capital A and capital B. Likewise, hexadecimal we have a base value 16, which means that going to has the value number symbols 0 to 9, and after the 9 we have capital A to capital F. So these are the digital symbols used for hexadecimal. Likewise, we have decimal, but the main number systems we are focusing are binary, octal, decimal and hexadecimal. So these are the main number systems we are focusing and using in the computer. So here we are seeing a decimal number system that starts from the 0 to 14. So 14 is not the maximum limit. Here it's just an example. So after the decimal we have binary, which is in the combinations of zeros and ones. We can easily identify the binary number system which is that contains only zeros and ones only. In the remaining number system we have some little bit confusion. So which is which number system? So that will be found by the base value that is represented in the particular number value. Next one is octal. Octal contains 0 to 7. After 7 we are having the numbers in the combinations of ones and zeros, that will be followed by after that 2 and zeros. Likewise, which is we are used in the decimal number system. So after 0 to 9 we are going to the next number after 9 is 10, which is a combination of 1 and 0. After that 1 1 1 2 1 3. Likewise, the combinations will be continued. Likewise, in the octal also after 7 there is no 8, so we are going to represent the next value using the combinations of ones and zeros. In the hexadecimal also we are going to use the same format. After 9 we are going to use the capital A and capital B, capital C, capital D, capital E and capital F. So capital F is the maximum limit used in the hexadecimal format, hexadecimal number system. So after capital F, the 1 and 0 combinations will be continued. First we are going to see about the binary number system. In the binary number system there are two number symbols used. One is 0 and another one is 1. All the numbers generated in the binary number system with the combinations of zeros and ones only. Likewise, the decimal number system, the least significant bit and the most significant bit. So LSD and MSD that are similar to the decimal number system. The LSD that will be happen in the right hand and the MSD that will happen in the left hand. So most significant digit is in the rightmost end and the least significant digit in the right MSD in the leftmost end and the LSD in the rightmost end. Here the position weightage will be given in the power of 2, which means the rightmost end digit that has the power value 2 power 0, the weightage will be 2 power 0, and the next symbol in the left side that has the power value 2 power 1. So likewise the digits weightage will be continued. Here is the sample representation. So binary number that contains the zeros and ones combination. Here the leftmost end that has the digit value 1. So 1 into 2 power 0. So 2 power 0 value is 1. We have already known that anything power 0 is 1. So 1 into 1 that gives the result 1. And the next digit in the left side is 1, and the 1 that has the digital position, the digit position is 1, and the 1 into 2 power 1. So 2 power 1, here the 2 represents the binary number system. So 2 power 1 means that gives a result 2. So 1 into 2 that will be the result 2, and after that we have a digit 0. So 0 into 2 power 2 means the multiple of 0 will given us a result 0. So the result will be 0, and after that in the third digit position the number is 1. So 1 into 2 power 3. So 3 represents the digit position, we have already seen. So 1 into 2 power 3. So 2 power 3 that represents 2 into 2 into 2, that gives a result 8. So 1 into 8 that gives a result 8. After adding 1, 2 and 8 we get the result 11. So which is in the decimal format. So decimal format will be represented by using the decimal base number 10. So that represents the given result is in decimal. Here we are representing 2, that represents the binary number system. So the given number is binary. Next we are going to see about decimal number system, which contains, already we have seen 10 different number symbols. Here 0 to 9 we have different number symbols, and the same format LSD and MSD formats also similar to the binary we have already discussed. Here the position is 1275 is the number, means here 5 that is in the rightmost end, so which is known as LSD. So least significant bit or digit. In that 5 we have a weightage is 10 power 0 and the next digit 7, so it has a weightage 10 power 1, and the next digit is 2, so it has a weightage 2 into 10 power 2, and the next digit position is 3, and it has the decimal number 1, and its which weightage will be 1 into 10 power 3. So 10 power 1, that gives a result 10. 10 power 2, that gives a result 10 into 10, which is 100, and 10 power 3 gives a result 10 into 10 into 10, which is 1000. So 5 into 10 power 0, that gives a result 5 into 1, the result will be the 5, and 7 into 10 power 1, that gives a result 70. 2 into 10 power 2, that gives a result 2 into 100, the result will be the 100, and 1 into 10 power 3, that gives a result 1 into 1000, the result will be the 1000. So the addition of 2 plus 70 plus 200 plus 1000 will be the 1275, so which is a decimal number that will be represented using the base value 10. Next, we are going to see the common rules of number system. So the points we have already discussed here, they are just combined or just highlighted. The numbers in the digital symbols, that will be equal to the base value, which means we have in the binary number system, we have two number symbols, two different number symbols. So the base value of that particular binary number system is 2, and for the decimal number system we have 10 different number symbols. So the base value of decimal number system is 10. So here the 10 represents the 10 different number symbols. And also the next point is the number system that is represented by the particular base number, that is 10, means the highest number, the highest value of the particular number system is 9. So 9 and 10. So 10 represents the base number, and 9 represents the highest number symbol that is represented by the particular number system. For that binary, the base value is 2, and the lowest value in that binary number system is 0, and the highest value in the binary number system is 1. So 1 and 2. So 2 represents the binary number system's base value, and 1 represents the highest number value in the binary number system. Likewise only we have all the number system. Likewise for the octal, the highest number is 7, and the base value of that binary number base value of the octal number system is 8. So likewise only we have all the number system representation. So these are the two main rules we are using in the number system format. And the another important rule is the representation of that particular number system. For the number 162, they are representing H in the subscript. So subscript means that will be used in the below one step below the particular number. Here 162 and H means the H represents the hexadecimal number system. So another format of representing the hexadecimal number system is using the number value 16. So 16 represents the same hexadecimal value. Here 162 is in hexadecimal number system. Likewise we are using the D, means D represents the decimal number system. The first letter of that particular number system here represented using the particular alphabet. Here 162 D means that gives a decimal number system. 162 10 means that gives a base value 10. 10 that represents the decimal number system. Likewise 162 O means that represents the octal number system, and 168 that represents the same octal number system. So 8 is the base value of that octal number system. So B represents the binary number system, and 2 also represents the same binary number system. So 2 represents the base value of that particular binary number system. Next we are going to see the conversion process, how we are going to convert the decimal to binary and binary to decimal. First we are going to see for whole numbers only, then we are going to continue with fractional numbers. For the whole numbers, we have two methods of converting from decimal to binary. In the first method, we are using the repeated division by 2. So we are going to convert the decimal number into binary number. In the decimal number, we have the number symbols 0 to 9. In the binary number, we have only two number symbols 0 and 1. For example, if we are dividing a number by 2, and you can take any number in the decimal number system, so that particular number will be divided by 2, means that going to give the result 0 and 1 only. So the remaining of that particular number, if we are dividing a number by 2, then the result, the remainder of that particular division process, we will get only zeros and ones. except 0 and 1 we will not get any other numbers. So it is the basic concept of converting decimal number to the binary number. So using this technique only we are going to convert the decimal number into binary number. Here we are taking a decimal number and we are going to divide that decimal number by 2. So while we are dividing, we will get a remainder 0 or 1, then we will get a quotient value. Again the quotient value will be again divided by 2. So again we will get some other quotient and the remainder. So likewise the process will be continued up to there is no further division, which means the quotient will be either 1 or 0. So up to that the division process will be continued repeatedly. Here is an example. We have a number 254 which is in a decimal. So 254 that will be divided by the number 2. So 2 that represents the, we are mainly using 2 for that represents the binary number system. So we are dividing 254 divided by 2 means that gives the quotient value 127 and the remainder will be the 0. Here the remainder will be marked in the separated from the quotient value using some lines. Here after 122 that will be again divided by 2, the quotient will be 63 and the remainder will be 1. So likewise the division process will be continued up to the quotient value will be 1. So while dividing 3 divided by 2 means that gives the quotient value 1 and the remainder value 1. So after we cannot further divide 1, that will be divided by 2. So 1 divided by 2 is not possible. So we will stop the process while we are reaching the quotient value as 1. So after that we are going to write the particular binary equivalent of the given decimal number. For that we are going to start from the quotient value and we are going to continue from bottom to up format. So after this one we are going to write out this one, after this one, after this one. Likewise we have nearly 7 ones that will be followed by 0. So that is the binary equivalent for that particular digit given 254, which is in a decimal number system that will be converted into binary number system that has the binary values. It's a combination of zeros and ones, 7 ones followed by 1 0. So that is the binary equivalent for that particular given decimal number 254. So this is a sample example. So 254 that will be divided by 2 repeatedly until we are getting the quotient value either 0 or 1. Next we are going to see about the second method, power of 2 subtraction method. In that power of 2 subtraction method we are going to calculate the power value of 2. So power of 2 value, we know that 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. Likewise the order will be continued. So first we are going to generate a tabular column that contains the weightage number which contains the power value of the 2. So 2 power 0 to up to 2 power 7 or 2 power 8 based on the given number that will be converted from decimal to binary. So based on that number we are going to draw a table that going to use to find the binary number. If they are giving a decimal number d means we need to take that d and we need to find the lowest lesser than or equal to that particular value d. So the particular value we are going to see is the power, the weightage number or the power value. So here let's take an example. Here the decimal number given is 247. It will be taken as a value d. Next we are going to see the value, so power value or weightage that is less than or equal to the 247. For that binary number system we have 2 power 0 to 2 power infinity level. We can see that we can see the possibilities, but while near to the 247 means we have two different possibilities. 2 power 7 that gives the result to 128, 2 power 8 that gives the result 256. So 256 that is greater than the 247. So we need to take the number that is less than or equal to 247. Here the number is 128 which is less than 247. So the next power value 2 power 8 is 256 which is greater than. So we just eliminate the 2 power 8 and we are going to take only 2 power 7, which is 128, and then we are going to represent 1 for that particular weighting factor here, that will be represented as 1. And the next step is we are going to subtract that 128 from the 247. Here the 128 taken as a value capital B. So capital P, that must be lesser or equal to the capital D. So once we have taken, then we are going to put 1 for that digital position in that weighting factor in that particular P, and next we are going to subtract B from D. So once the result generated, if you are subtracting 247 from 128, then the result will be 119. So 119 means again we are going to see the weighting factor. So less than or equal to the 119 weighting factor here is 64. So 2 power 6 that gives the result 64, and 2 power 7 that gives the result 128, which is greater than the 119. So we are just eliminating the 2 power 7, and we are going to deal with 2 power 6, which is a number 64. For that we are going to have a binary number. You are going to represent the binary number 1, so we need to mark it as 1, and then next we are going to subtract 119 from 64. So we are going to subtract 64 from 119, and the result will be 55. Then again we are going to see the lesser or equal weightage number. Here it is 32, so we are marking 1 for the 32, and again we are going to subtract 32 from 55, and the result will be 23. So next we are going to see the lesser or equal value. The result is 16, so it is lesser than the 23. So the we are going to mark 1 for that 16, and then again we are going to subtract that 23 from 16. The result will be the 7. So for that 7 we are going to looking that weightage means here 8, that is greater than 7. So we just eliminate that 8, which means we are going to put 0 for that 8, and for the 4 we are going to put 1. So 7, that is lesser or equal weightage is 4. So we are going to put 1 for 4 and 0 for 8. So here we are representing 0 for 8 and 1 for 4, and then next we are going to continue the process, and we are going to eliminate, we are going to subtract 7 minus 4, the result will be 3. So lesser or equal to 3, the power value is 2, and then next we are going to put 1, and then we are going to again subtract 3 minus 2, the result will be the 1, and for 1 also we are going to put 1. So we are going to stop that process until the weightage is 2 power 0 or furthermore numbers to perform that subtraction process. Here the final result of that number, the given decimal number 247, that will be converted into binary number, means the binary result is 4 ones followed by 1 0, and then 3 ones followed by that 0. So this is the conversion of 247, that is converted from decimal to the binary number system in the method 2. So the method 2, that is known as power of 2 subtraction method. So power of 2 means we are going to see the power value using the weightage number 2 power 0, 2 power 1, 2 power 2 up to etc. And the subtraction after, once we have seen that power, then we are going to subtract that particular number. Here we have 3 different steps. First we are going to take that decimal number D, as D, then we are going to find the power value which is capital B, and we need to check that P, that is less than or equal to D. If the B is less than or equal to D, then we are going to subtract B from D, and the numbers will be interchanged, and then again the B will be the new D, and the new P we need to find out which is the less than or equal to factor, weighting factor, and we need to put 1 for that particular rigid position. Likewise the process will be continued. If we could not find that D, that is less than P, means we need to put 0, and then the remainder, the process when we are going to stop means once we are reaching D is equal to 0, the process will be stopped. Next we are going to see the conversion of a binary from decimal. So here we are going to see it for only the whole numbers. Here we are going to convert a binary number that is given as 110101, that will be represented as binary using the base value 2, and we are going to convert it into the decimal number. For the binary to decimal conversion, we are going to multiply that particular digit using the associated weight. Here we are going to take that that contains the value 1. So 1 into 2 power 0 means that has the that will give the result 1, which means 2 power 0 means that will be 1. So anything power 0 that gives the result 1. So 1 into 1, that will be the result is 1. And after that, in that left hand position, in the left hand digit position, we have a value 0. For that 0, the digit position is 1. So 0 into 2 power 1, that gives the result 0. And then the next position is 2. In that second position, the binary number is 1. So 1 into 2 power 2 means that gives a result 1 into 2 power 2, that gives a result 4. So 1 into 4, that gives a result 4. After that, we have the third digit position that gives that has the binary value 0. So 0 into 2 power 3, that gives a result 0. And after that, we have a digit position 4. So we have the binary number 1. So 1 into 2 power 4, that gives a result 2 into 2 into 2 into 2, that gives a result 16. So 1 into 16, that gives a result 16. After that, we are going to see the next position value, which is 5th, that has the binary number 1. So 1 into 2 power 5 means that gives a result 32. So 2 power 5, that gives a result. So 16 into 2, 2 power 4, we have a result 16. So one more power we need to add, which means that will multiply by 2. So that gives a result 2 power 5, that is 32. So 1 into 32 means that gives a result 32. So we are going to add the all decimal values, so that the result will be 53. Here the binary, here the conversion process of binary to decimal will be performed by using the weighting factor. So that is power of 2. Using that only, we are going to convert the binary number into decimal. So we have two more important points. To convert any number system into decimal, we are going to use the expanded notation, which means power of that particular value. In the decimal number system, from a decimal number system to any other number system means we are going to use the division method. Likewise, we are seeing, so decimal to binary, we are using the repeated division by 2. Likewise, any decimal number system to any other number system means we are going to divide by the base value that is correspondent to the particular number system. From any number system to decimal means we are going to use the expanded notation that we have already discussed. Next, we are going to see about the fractional numbers. In the fractional numbers, we know the common format we are using in the whole number, in the natural numbers. In the natural numbers or fractional numbers, we are going to, after the dot value, in the left to the dot, we have the position, unit position, and the 10th position, 100th position. Likewise, we are having in the decimal number system, we have a 10 power 0, 10 power 1, 10 power 2. Likewise, in the left hand side, the power will be increases to 1. In the right side of that 10 power 0, we have a negative values, 10 power minus 1, 10 power minus 2, 10 power minus 3. Likewise, the number system will be continued. For the binary weightage, the same will be followed. 2 power 0 is the whole number system right and utmost right hand position. So after that, 2 power minus 1, 2 power minus 2 will be used for the fractional numbers. Next, we are going to see the decimal fraction to binary. So how we are going to convert the fractional decimal numbers into binary numbers. Here we are having a number 0.375. It's a decimal number that will be represented using the base value 10, that will be converted into binary number by using the method repeated multiplication by 2. So for the conversion of decimal to binary for the whole numbers, we are going to do the operation repeated division by 2. For the fractional numbers, we are going to use the multiplication process repeatedly by 2. Here 0.375 means we are going to multiply the number 2, multiply by the value 2, so that gives a result 0.750. So before the dot, we have the value 0 alone, and after that 0.750 we have received. Next, we are going to do the multiplication process again. So with the value of 2, we are going to do the multiplication, that gives a result 1.500. So before the point, we have the binary digit 1, so that will be taken again. The again the fractional position only we are going to take, and we are going to do the same multiplication process again. So that gives the result 1, that followed by the fractional numbers with only 0. So the result we are receiving is 0 1 1. So we are going to do the multiplication again and again for the fractional portions only, not for the whole number portion. So whole number portion will be taken as a result here, and the fractional portion will be used for performing the multiplication process again. Here the process will be continued up to there is no more fractional numbers to perform that multiplication process. So we have only zeros, means we are stopping the process that position. Here another example, 0.29. So it's a decimal number, so that has the base value 10. So that will be converted into binary. Here after some particular amount of time also we did not get that 0 in the fractional side, so we can stop after 16 digits. So that's enough. In for the general decimal number system, we are going to stop the fraction after 2 digits. So that's enough for maximum approximation. For the binary number system, we need 16 digits, so 16-bit position for the approximation process. Here is the example for that. Next we are going to see the binary to decimal conversion for the fractional numbers. For the binary to decimal conversion, so 0.1011 is the given binary number that will convert into decimal number. So the last position, the rightmost end, we have the decimal, we have the binary number 1, so that will be converted into decimal number 1 into 2 power minus 4, so which is the fourth position, that represents the fourth position. Here after the dot, so which means after the dot means in the right hand side that represents the position 2 power minus 1. So in the left hand side that represents the position 2 power 0, and before that 2 power 1, likewise it continued. So in after the dot means after the dot, the right hand side position, the first digit is 1, so that will be, that has the weightage of 2 power minus 1. So next digit that has the position 2 power minus 2, so next one that has the weightage 2 power minus 3, and the last digit 1 that has the weightage value 2 power minus 4. So likewise only the binary weightage scheme will be followed for the fractional numbers. Here 2 power minus 1 that represented by the 1 by 2, so 1 by 2 that gives a result 0.5, and for the 2 power minus 2 that will be represented by 1 by 4, so 1 by 4 that gives a result 0.25, and the next one 2 power minus 3, so 2 power minus 3 that gives a result 1 divided by 8, so 1 divided by 8 that gives a result 0.125, and 2 power minus 4 that gives a result 1 divided by 16, so that gives a result 0.0625. Here we have a binary value 1 at the position minus 1, so which means 182 power minus 1 that gives a result 0.5, and the next digit is 0, so 0 into 2 power minus 2 that gives a result 0, and the next position is 1, so 182 power minus 3 that gives a result 0.125, and the next position is 1, so 182 power minus 4 that gives a result 0.0625. so the addition of that 4 that gives, so which is a decimal system that's converted from the given binary number 0.1011. so the corresponding decimal number for that binary number 0.1011 is 0.6875. Next we are going to see about the addition and subtraction process which is going to performed in the binary number system. Here we are going to see the rules for binary addition. Here we have 4 different rules. First rule is 0 plus 0 that gives the result 0, and the next rule is 0 plus 1 that gives the result 1, and the third rule is 1 plus 0 that gives the result 1, and the fourth rule is 1 plus 1 that gives the result 1, that's followed by 0. Here the 0 will be taken here, and the 1 will be taken as a carry. Here we are going to add 2 different numbers, so which is 15 and 6 that given in the decimal number system that will be converted into binary number system. The binary equivalent of 15 is 4 ones, and the binary equivalent of 6 is 0 1 1 0. Here we are going to add the 2 different numbers, so 4 1 and the 0 1 1 0. Here 1 plus 0 by using the rule 3 the result is 1, and the next 1 1 that follows the rules 4, so that gives a result 0 and the carry 1. So we have seen 1 0, here 0 is the result and 1 will be the carry. So here we are going to take 0 as a result and 1 will be the carry. So again we are having triple ones. For the triple ones we are going to add first carry and the first digit 1, and the result will be added to the further one. So the result give me 1 1. So 1 1 means that